Alright, so this is writing exponential growth 1. We covered this in class on Monday, but we'll go ahead and look at it again just to fill in a couple of these blanks. Now, when we see here what we're looking at for this first part, when we have exponential equation in the form y is equal to a times b to the x, we have growth when our b value is bigger than 1. Anytime we're multiplying by a number that's larger than 1, it will be growing. Alright, and we also know that our a value is our starting spot, or our y-intercept. Alright, so then it gives us a couple of instructions about how to write out these types of problems, but we'll do it by looking at this first example. Now what we'll want to do is go through and identify what is our starting value. And we can see from the problem that it tells us we have a population of 30 rabbits. Right there I see that 30. Now to find our b value, a lot of us do this in our head, but this is kind of just showing us the math behind those steps. Right, and what it is, we have to take our percent. We're dividing it by 100, which a lot of people know is just moving the decimal spot 2 spots to the left. Alright, and then since we're growth, we have to add 1 onto it. Growth is always 1 plus our decimal. Alright, decay is going to be 1 minus when we get there, but this will be 1 plus. So that's going to be our b value. Now when I put this a value together with my b value, we'll get our final equation. Don't forget to put your x up top in the exponential area. Alright, now so that covers that. So it says follow the same steps on the back side. It's going to be the exact same steps here for us. Make sure you keep track of things such as like 7% might be 0.07, right? It's not a 0.7. What I do want to look at though here is number 6. Is a plant starts off 2 inches tall, so that's our a value. It has a growth rate of 150% every week. So I'm going to put that growth rate in there. We need to divide it by 100. Right, so some people will get here and they'll say, I don't need to add 1, I already see 1. But that's not true. If we're growth, we always must add our 1 in here. This b value is a 2.5. Because if I'm increasing by 100%, that means doubling. So we see a 2 here. And then we also have that additional 50%, which we can see right there, which makes our final equation this. It already has the y equals here for us. That's what it's going to look like there to write that equation. All right. Now this page where it says estimating with exponential growth, that's going to be where we're doing the same steps, but this time it's going to ask us to plug in a value at the end. We'll talk about how we can do some rounding and such. Okay. All right. So for the first one here, a population of 75 tigers is increasing at a rate of 45% per year. It wants us to write our equation out. So the steps I'm taking here are the same steps we saw on the other side. So once I get here, I've got my percent as a decimal, and I add that 1 to it. All right, and then we can use that to write out our exponential equation. All right, and then the next question is, how many tigers would we expect in the population after 4 years? And it gives us a box where it says expression to be evaluated. That's where we're going to rewrite our expression, but instead of our x, I need to plug in what it's asking me to plug in. All right, so since it asked for 4 years, that's where this 4 is coming from. And now we'll be able to evaluate this using our calculators, or maybe using the internet at home, using that up arrow key on the keyboard, just like we would on our calculators to find our answer. All right, so here's us with our calculator. Now we need to plug in our equation. Here's the up arrow to get our exponents. It's the same button you can find above the 6 on a keyboard if we need to type it in online. Now, this is the answer we get, but we have to think about what type of unit we're working with. Since we're talking about tigers here, we're going to want to round to the nearest whole number, right? I can't have decimals of tigers. So back here on my page, we're going to want our answer to be expressed with units. Now be sure to include the units on our answers and use that to inform you about what type of decimal rounding we need to do. If we're talking about living creatures, it needs to be the nearest whole number. If we are talking about money, you can have 2 decimal spots, right, for the change on the dollar, all right? And that's the way this side works. Now keep in mind, once you get to the back, they've taken away our template, but we still have to do that step to find this b value, right? If I wanted to find this b value, I still need to do the 1 plus or percent as a decimal. I took away the template, but the same process is required there to be successful, all right? Now let's talk about writing exponential decay. This is going to be a very similar process to what we just saw, right? Except now, when we're looking here, we know that our b value, when we're decay, has to be in between 0 and 1, right? It can't be negative or 0 or 1. It has to be pocket change. And our a value is still our y-intercept. All right? And so these steps you'll recognize very similar, except now we're going to be doing 1 minus our decimal. All right? Because that's the way decay works. It's not 1 plus, it is 1 minus. So let's look at our example here. This is a city with a population of 50,000. That's our a value. All right? It has a decay rate of 4% each year. When we divide it by the 100, we get a 0.04 because 4% of a dollar, 4 cents, 0.04. Now to find our b value, we need to do 1 minus this decimal. Right? Because 1 represents the whole, and we're subtracting the part that we are taking away. We're taking away that decay. So our b value here will be a 0.96. So when we go to write that final equation, we have our a value, we have our b value, and that's what our final equation will look like there for us. All right, and you can notice this b value is in between 0 and 1. That's how I know that it is decay. So follow the same steps on the backside, right? So you'll see a lot of similarities between the growth and the decay. But remember, this one is always going to be 1 minus as long as we're talking about decay. This page here works in a similar fashion. You'll still be just writing out your formulas, right? So I'll talk about this one. So we're on estimating with exponential functions decay, part 1. So we find our starting value of our population of elephants. We see we're decreasing. That's how I know we are exponential decay. So I'm going to put that in. All right, so 19% as a decimal is a 0.19. Now we still need to do our 1 minus that decimal. Which leaves us left over with 0.81, right? If I had $1 and I spent 19 cents, I have 81 cents left over. So here's our exponential equation. It's going to look just like that. Now it says, evaluate how many elephants would we expect after 7 years. So this is the expression we'll be looking for. We're going to write that in, but instead of x, we'll replace it with this 7. Right, and we can use our calculators to help us estimate this. All right, now once again, we're talking about elephants as a whole number. So we have to take a look at the 691. I see it's a 0.5. That 0.5 is telling me to round this 1 up to a 2 here for us. All right, so our answer will be